Just give another minute and you can start, Priyanka. Yeah, Priyanka, you're good to go. You can start.
Okay, great. Hey everyone, good afternoon or good evening, wherever you are. Um, yeah, good evening, Nigel. Thank you for being here. Um, Thank you for having me. Today I'm going to be talking to you about some networking fundamentals. Um, My name is Priyanka Mahankali. I'm a solutions architect with AWS, and I've been here at AWS for close to 4 years. It's been an exciting journey for me. But before we dive into the specifics of some networking concepts, I wanted to start by sharing a little bit about myself. Please feel free to ask any questions or anything. Let's keep this interactive. So yeah, as you can see, I have five country flags, and that's because I actually lived in five different countries in my whole lifetime so far. And majority of my time was spent in Saudi Arabia. Uh, so 18 years in Saudi, and then Dubai a few years, and then India for my undergrad, then moved to US for my master's, and then that's where I started my job at AWS. And then I moved to Canada about a year and a half back to Toronto, and I'm currently based out of Toronto. So yeah, I think when people ask me what's interesting about me, I don't know what to say, but but I think this probably is the most interesting thing, that I actually lived in five different countries. So I have a lot of interesting perspective around cultures and sort of how different people live in different countries and how they see the world. um, and then moving on to my family life, I actually, initially, when I was in my undergrad, I used to do modeling as part of my hobby, because I was very inspired by a lot of models growing up, and my mom, she was very into me being a fashionista and all of that. So I was I did some good amount of modeling at that time, and actually gave me a made me feel confident to take the stage and represent myself in the way that I wanted to. So it was interesting, and I still do it. I still do modeling in a smaller capacity, obviously, because I don't have time for anything else. But yeah, that's one of my passions. And then you can see a picture on the left hand side is one picture of a very old picture. It's probably like 5, 6 years back, because I don't have a recent one that I can share. So yeah, it's one of the things that I'm happy that I did. And then in the middle, one of my other accomplishments is actually represented by my family being in United States. So a little bit history about that is my whole family was in India and in Saudi and in Dubai, and it was one of my dreams that I could, you know, make enough money, have my house, and get them there, and spend some time with them in US. So, 2 years back, I made my dream come true. So that was a huge deal to have us all four in the same roof. So, yeah, I consider that one of my accomplishments, because it is a symbol of my personal accomplishments, because of which I was able to bring them all under one roof in the United States. And then, yeah, the last picture is just a representation of my current life. I'm based out of Toronto, so this is just a recent picture of me in Toronto, in one of um, the ice skating grounds. But yeah, that's a little bit about my what I kind of where I'm currently what I'm currently doing. And then there was a demand from from my cat saying, you have to have my picture there. So yeah, well, this is, according to her, the most important slide. Yeah, I have a cat. Her name is Jasmine, and she has been my companion through the pandemic. Since just me and her in the house. So yeah, it's yeah, she's funny and at the same time naughty. The second picture of her is her in in this really naughty, mischievous mood. So that's why I thought that picture was interesting. And the first one on the left side is one with her attitude as well as her cute face. So yeah, that's a little bit about me. And I also wanted to share that I sort of had a very straightforward path into technology, where I did my undergrad masters, and then I moved into technology. But that doesn't necessarily is not necessarily what I have seen across the board. I've seen people coming from different fields. Today I just met somebody who's from the Amazon fulfillment center, started their journey there, and then worked their way up into robotics is something that they really wanted to do. So yeah, there are many ways of getting into technology. And I encourage you to explore what you really like doing in technology, and how you want to impact, how you want whatever work you're doing to show in the world. And then, one last, one not last, one important advice that somebody gave me. It's not really advice, but it's more of a saying that I sort of live by is, nobody knows everything, but everyone knows something. And I think it's really impactful, and I think it, keeps you grounded. At the same time, uh, makes you feel like, okay, you definitely, like, we all definitely bring things to the table that we should all be proud of, while knowing that everybody also brings something else. And at the same time, we all don't know everything, so that also keeps us humble. So that this is something that I live by, and I try to incorporate it in everything I do, and whatever I talk or however I behave. I don't know if that would be helpful to you, but this has been helpful to me in many situations, to keep me grounded. And I think that's one of the I think, as we think about our career, I think it's sometimes difficult to stay grounded, and sort of try to be the person that you always wanted to be. And so that's why it's like good to have some quotes or things to live by, so that you can keep reminding yourself of that, and it keeps you grounded. I think that's one of the really important things, to be humble in whatever you do and how much ever you know over time. With that being said, let's get started on the networking fundamentals. And I apologize for the next slide, because it looks a little bit boring, but I did want to start by talking about the sort of basics of networking, even like not just AWS. I didn't want to start with just AWS fundamentals, but I wanted to start by talking about an important concept that will help us understand throughout the rest of the presentation what IP addresses are and what they really mean from an architectural standpoint, and where you really how you really need to make decisions when it comes to IP addressing. So, as you can see in this slide, you have at the top, right, you have 192.168.10.0/26. So don't look at anything else in the slide. Just look at that number at the top, at the very top. that number basically represents what we call as an IP address. Okay, and an IP address is basically a way to address an IT resource, whether that's a virtual machine, or or whether that's a server or whatever that is. So in order to address something over the internet, we basically need an IP address so that you can address it to that particular machine, right? So it's simply like you having a name. So if you didn't have a name, how would people address you? Right? How would people, or if you didn't have a mailing address, how would people reach you? So it's just like that. So now that you know what an IP address by definition means, I wanted to introduce you to a specific type of IP address called classless IP address. So the IP address you can see here at the top is a classless IP address. If you want to know more about it, there are a lot of there's a lot of material online to know more specifics about it and how it sort of came about. But basically, classless IP addressing typically has a slash notation. So at the end of the address is basically 192.168.10.0. At the end of that address, you have a slash and a number. So it's a slash n notation. And that slash n notation is what we call as classless addressing, right? And what that means is that the number 26 or n/n in general uh, basically determines the number of network bits that are associated to an environment. So let me give you an example, right? So in any environment, right, you would have a network address, which is like the main sort of distinguishing address, and then within that address you will have actual hosts or like virtual machines that are actually going to be using that address. So basically the slash 26, right, tells you what is that unique network address, and then everything after that is basically the host address. And what I mean by everything after that, I'll tell you what that is. So as you can see here, you have the this box, right? So now let's look at that box, those four boxes from the left to the right. In that we have, as you can see, all ones at the bottom, right? And basically, so ignore the ones, just think about the four boxes, and these four boxes represent each bit. Okay, so think of it. So and a total IP address consists of 32 bits. So 8888, and that's what is represented by these four boxes, each with 8 bits, right? So 192 is 8 bits, 168 is 8 bits, 10 is 8 bits, 0 is 8 bits. So each is 8 bits. So when you convert the hexadecimal to binary, then you'll basically get 8 bits, which is what this ones is talking about, right? So total you have 32 bits. So the reason I mentioned that and why that's important is because when you say slash 26, it means that 26 bits out of the 32, which is the full IP address, 26 bits out of the 32 bits are assigned for the network address. That means they cannot be touched. They are assigned as a network address, which is the unique network address. So anything after 26, which is 32 minus 26, only those number of IP addresses you can actually use for your hosts. That means your virtual machines, or your servers, whatever you want to call it, right? So keeping that concept in mind of what slash 26 or what slash n means, now you can look at as you can see here, when you're looking at architecting an application, right, on AWS, or in general, you you want to be able to define an IP address for your particular application or workload. So in order to make sure that you have you define a range that basically has enough hosts, because if you define a range that has majority is network address and you just have a few remaining as hosts, then that would be a problem if you're trying to scale or expand your infrastructure to support more IP addresses. So keeping that in mind, right, you want to be able to first calculate how many hosts you would have if for a /26 IP address, for example. So when you say /26, right, that means everything before the 26, like I said, is allocated to the network. That means until here, as you can see in this arrow that I'm showing here, everything until here is cannot be touched. So you cannot use that for hosts, right? So now you have only this rest 6 bits that you can assign as host addresses. How to calculate how many combinations of these bits that you can have, because now these bits basically you can add them as different combinations, and basically each of them becomes its own IP address which is assigned to a host, right? So all you need to do is two power the number of bits that are available for the host. That is 2 power 6 in this case, which is 64. So basically now you have 64 free IP addresses within the /26 range, right? Because this, like I said, the everything until the 26 is assigned as a network IP address, so you can't change that. Just one caveat to that is that yes, 64 is the total number of IP addresses for the host, but we need to minus 2 from that. Why? Because one will be the very first one will be taken for the network address, like the overarching network address, and the last one will be taken as for the broadcast address. If you want to know specifics of that, I don't want to share too much specifics. I mean, because this is a whole subject in itself. But all you need to know is that you need to minus 2 from the total number of hosts. So if it's 64, 64 minus 2 is the total number of hosts you can actually use, total number of hosts that you can create with this particular with this particular slash notation, that is /26. Now, the reason I'm telling you all this is because you will see in the next few slides that you'll see /18 or /16. So then if you see /16, that basically means you have 16 addresses assigned, 16 until 16 bits. It's assigned as a network address, so you can't touch. So rest remaining is what, 16, right? Because total 32. So rest 16 you can assign, 16 bits you can assign for the host. Now how do you know how many combinations of that are there? 2 to the power of 16. So that's how many hosts you can basically have for that particular. And keep in mind, 2 to the power of 16 minus 2. Always minus 2, because that 2 are allocated for one, the network range, and one for broadcast address. Okay. I encourage you that if you want to learn more about it, it's called classless IP addressing, and you can learn more about how to convert hexadecimal to binary, binary to hexadecimal, and how do you sort of really understand what the bits mean, right? But just for the context for the rest of the presentation, just want you to again understand what that slash notation means and what implications that can have to your application design, not to your infrastructure design, right? So, any questions on this? Because I know this is a very deep topic, but any questions on this? And I cannot really see the questions. So if you can unmute yourself, that would be great. Or if somebody can um, help me with that. Any questions? Okay, I'll take the silence. Pardon me? Okay, I'll take the silence as no questions yet. But feel free to ask me any questions if you have any. Okay, so now let's move on to the AWS portion of networking. So, and let's start with what is a VPC. So maybe you might have heard of it, maybe you might have not, but I will assume that you have not heard of it. So a VPC is basically a virtual private cloud, and this is basically your house. It's where your applications are going to be housed in the cloud. And the reason why your applications are going to be housed in a VPC is because a VPC is actually your network boundary. It's a virtual network boundary that that is yours to maintain, that is yours to provision, and that's yours. Everything within this network boundary belongs to you. So all your applications that you deploy in AWS, you can put it in your VPC, because all of those applications need IP addresses, right? Because they need to be addressable. Because how are you going to address those applications? So anything that needs an IP address and needs to be addressable, either through the internet or privately, should sit within a VPC, right? So when you are like, for example, if you're creating an instance, or what we call a virtual machine as an instance in AWS. So when you're creating an instance in AWS, you'll see on the console that it'll ask you which VPC do you want to put it in. And if you don't have a VPC yet, you'll have to first go create a VPC and then put the instance into that particular VPC, right? Then we'll talk a little bit about some fundamentals of IP addressing and subnets in the next few slides. Okay. And first off, you want to start by choosing an IP address range, and this is where the concept around the slash notation will help you understand how to make that decision around choosing an IP address range. So, as you can see here, we have a /16 notation. So the /n is a /16 here. That means the first 16 bits are network address, so they are reserved, you can't change that. The last 16 are for the host. Last 16 means 2 to the power of 16 minus 2, right? So then you can decide, oh, is this enough for my organization to, as we for our current needs, and as well as when we scale and we require more virtual machines to be installed within this environment, right? Because you also want to prepare for scale, so you want to be able to assign somewhat of the right number of IP addresses for based on what you think your current needs are and what your future needs might be. And even as a solutions architect or as an architect, you want to be able to understand, and you want to be able to ask those questions like how many hosts do you anticipate having in the near future, and make those decisions, make those IP range decisions based on that. Because once you assign an IP address to a VPC, you can't change it. So you all you can do is create a new VPC, and then create a new IP address range for that. But you can't change an IP address range once you create a VPC and define an IP address range for that particular VPC. So you definitely want to make the decision with some information on how many hosts you want to have within that particular VPC. Now, so now that we have assigned an IP address range, now let's go ahead and create some subnets. So what really are subnets? So we talked about, a main IP address range, right? And then we talked about the /16 notation. Subnets are basically, think of them as subnetworks of a overall network, which is the one you see on the screen. There's the 172.31.0.0. The reason we have what we call a subnet is so you can create some segregation even within a full network. You can create segregation based on, like, you can have test workloads, production workloads, development workloads in separate networks, so you can isolate them from one another and create different kind of access policies to each of those accordingly, right? And then also create some hierarchy and around your network for different kinds of applications. So as you can see, you have 3 different subnets, okay? And you have created those subnets within your VPC, right? So now these subnets will have an IP address range that will be a sub range of the main range. So as you can see here, since this is /24, right, that means the first 3 bits are taken for the network. But here you basically have but the way the subnets are also unique is because the first one you can see is 172.31.0, second is .1, third is .2, and that's how they are still unique from each other, even though the last bit is 0, right? So they are unique within their own domain, but then they all belong to a IP address range, which is defined in your VPC. So now once you have defined subnets, right? Now you want to understand what routing, how do you have different subnets talk to each other? Because maybe you might have your database in one subnet, maybe you might have your application in another subnet. So you need them to talk to each other, or you might have applications themselves that need to communicate with one another, right? So you can have what we call as route tables. So once you define route tables, it's basically like saying, okay, I'm going to basically tell each subnet how they can reach the other subnet. And that's what basically a route table is. It's just giving instructions for how other subnets can be reached. And based on the route table inputs, those subnets can communicate with other subnets. Okay. So in AWS, you can create route tables in your VPC, and this is what it would basically look like. It would have a destination, it would have a target, and in this case, as you can see at the very top, the target says local. So local basically means that all the communications are within that same subnet. They do not, that route is basically for all communications within the subnet itself, not outside that subnet. Okay. And that's what local means, because you could have different VMs or virtual machines inside the same subnet, right? So how would you want them to communicate with each other? Through this route table, where you define this IP address as a local. Then I'll talk about the rest later, but basically you can also have other destinations, such as the internet. So for the internet, since it's all any and all IP addresses, it's 0.0.0.0/0, and the target is to a internet gateway, and I'll talk about that a little bit later. But that's what route tables do, and that's, the way you define route tables is is in a subnet and a VPC. Okay, then you have what we call as security groups. So now we're looking at network security. Till now we've talked about routing, we've talked about how to establish an IP, how to think about an IP address range, how to establish that range by having a VPC, and then how do you create sub networks so that you can isolate your workloads within a VPC. So we call them subnets, and we assign IP address ranges to those subnets as well. Now you want to think about security, right? So for security, let's get started with the first concept, which is security groups. And this you will hear time and again. This is a very important one. So security groups are basically, okay, so let's start. Let's take it this way. So you have your application, so you have your web tier, right? And let's say you have your app tier. So how can you make sure that your virtual machines, or these boxes which represent virtual machines, right? How do you make sure that they are the whatever your application that's sitting inside it is secure from any malicious activity from a network standpoint? So basically, can anybody from the internet access the application? Can anybody from the internet access your app layer or your database layer? Of course not. You don't want that, right? So therefore, that's where security groups come into picture, where these security groups act at an instance level. Okay. And from now onwards, I'll use the term instance instead of a virtual machine. So each security group acts at an instance level. So each box essentially has a security group attached to it, and security group is basically a rule. So you're defining what the rules are for accessing your web tiers and your application tiers and your database tiers and whatever you have, right? For example, you can create a security group rule that says, okay, allow all web traffic on 0.0.0.0/0. That means allow all web traffic, all IP addresses are allowed, right? And let's say maybe this is a public facing web application. That's why that rule makes sense, right? What about your app layer? Do you want that? Do you want access? Do you want the same rule for the app layer as well? Like allow all app traffic on 0.0? Of course not, right? Because your app servers don't need access to the internet. They'd rather be, you want to follow the principle of least privilege, where you want to keep them secure in behind the web layer. So what you do is you can create a security group rule for each of these boxes, right? Each of these instances, and say that only allow traffic from my web servers, because obviously web servers need to then communicate with the app layer to process the requests, right? Only allow traffic from the web layer and nothing else. So basically, then your application layer has no access to the internet. So the attack surface is reduced now considerably, right? And where you would implement these security groups, this is basically what it looks like. So actually the name sounds kind of, it's big and sounds like it's some big thing, but actually in reality this is what it looks like. It's a rule. So as you can see, the type is HTTP, transport protocol is TCP, port 80 for the TCP, source is all IP addresses. So this is the security group that's defined for the web layer, right? The one that's receiving all the traffic from the internet. And similarly, this is for IPv6. If you don't know what that is, then yeah, you can look it up. But it's basically a different type of IP address. Then for the application tier, this is what the rule would look like. As we talked about, you're creating a custom rule that's saying that only allow traffic from the web server. So here it's actually web server, right? So basically that's what it would look like. You would just, click a few buttons and you would basically create a rule, an inbound rule. Okay. Now let's move on to what we call as network access control lists. We talked about security groups, which is one type of network security. The other type of network security is network access control lists. So in this category, basically what a network access control list is that it is the same concept where you're implementing rules, just like the security group, but the only difference, or one of the differences, is that the network ACLs operates at a subnet level. You remember we talked about how security groups apply only at the instance level, right? Which means for each box. But the network ACL operates at a subnet level. So it's a much higher level. So subnets, if you remember, that are within the VPC. Okay. So both of these are complementary. They're not supplementary. They're complementary to each other. Customers use both in different situations. Security groups are mandatory to use. You need to have at least one by default, one security group rule. You can have more than one, of course. Network ACLs are not mandatory, but they are recommended. Then some other key differences are that network security groups, they are basically stateful, meaning that they have memory. So this is one key thing to remember, is that security groups are stateful, so they have memory. So when they allow certain traffic, right, when you basically create an inbound rule, that means you're defining a rule for what traffic can enter, right? So because security groups are stateful and have memory, they basically will allow allow return traffic to be automatically allowed regardless of any explicit rule that okay, this the traffic that has entered can also exit, right? So basically by default security groups are do not need explicit do not need explicit rules that the traffic that is entered cannot exit, right? So all traffic that enters can automatically exit. That's what basically security group rule is, because it can keep memory of what traffic has entered. On the other hand, network ACLs, they do not have memory, right? So they basically, it's almost like they're not being accountable. They don't have memory, which means that you need to explicitly mention that, okay, if I accepted this traffic, if this is an inbound rule, then I need to explicitly mention an outbound rule as well, because otherwise it's not going to allow that same traffic to exit, because that's what network ACLs are. They are stateless. Okay. So those are the two main, you know, there are differences that you should remember, which is stateful, stateless, and it operates instance level and at a subnet level. Okay. Then, so the last topic in network security is VPC flow logs. Now, VPC flow logs, right? We have you ever wondered about, okay, yeah, you have set up a VPC, you have your subnets, you have your instances, and they're all functioning. Okay, you're receiving traffic from the internet, all of that great stuff is happening, right? But what about if you want to know what kind of traffic overall at a VPC level are you receiving? And for you to also assess, your security posture, and make decisions on, are my security group rules too restrictive? Are they less restrictive? Should they be more restrictive? So you can make data-driven decisions. You want to make data-driven decisions on based on what kind of traffic is actually entering overall, right, into your VPC. For that, we have VPC flow logs. VPC flow logs is a feature of VPC that allows you to log all traffic that's entering the VPC. Okay, and this gives you visibility, obviously. Then it allows you to troubleshoot for any issues, and then overall it allows you to analyze trends, right? So you can see trends in your traffic patterns. You can also integrate VPC flow logs with something like a Kibana dashboard, right? So that you can visualize these logs and make some decisions. Now, what a log would look like, I would look like this. You don't have to remember these things, but it's just for your knowledge that, okay, well, you have an AWS account. It shows you the account that the VPC is in, that the traffic, this particular traffic is coming into. One key thing you need to understand is that it has a source, destination, as well as the last component, which is accept or reject. Because based on whether that particular traffic was accepted or rejected, you can make decisions on your security group rules and your NACLs, which is network access control lists. You can make decisions on how restrictive you want to keep them, whether it's more restrictive or less restrictive, those kinds of decisions that you can make. And also you can analyze trends over time, like what kind of traffic is being rejected, maybe during what times of the year, that sort of a thing, right? Any questions before we move on to the next topic? Okay. So now let's talk about some connectivity options for VPCs, right? So now that you have defined your VPC, you've set up everything beautifully. You have your IP addresses, they're addressable. You have your subnets, all of that, right? But now you want your VPC to connect either to the internet, or you want to connect to other VPCs where maybe other applications are, where maybe two applications sitting in two different VPCs need to communicate. Or you might want to connect you may have some workloads in your VPC in AWS cloud, and some workloads may be still on premise in your data center. So if you want them both to communicate, you need a connection, right? So for different kinds of connectivity options, let's talk about that. So you have your instances, right? Inside your VPC, as we mentioned, right? You don't have to necessarily know about all the services that are at the top, but yeah, they are basically different AWS services that if you want to read about, you can. Uh, and basically, the way you can set up connection between the VPC to the internet is through what we call as an internet gateway. So this is another concept as a feature. It's a feature in the AWS console where you can basically establish a connection with this for the subnet with the internet gateway, thus providing access to for the subnet to the outside world. Okay. At the same time, you also have to make sure, and we didn't talk about this earlier, but I'll talk about it now, that we also have two kinds of subnets. One is the second, yeah, one is the public subnet, and the other one is a private subnet, right? So till now, we in the beginning I talked about a general IP address, right? But I didn't talk about the fact that we have two different types of IP addresses. One type of IP address is assigned for private use, means it is only addressable within a private network. It's not accessible to the internet. That means if you just type that IP address on your browser, it will not show up. The page will not show up, right? And then there are IP addresses that are specifically designed for being addressable over the internet, and we call those public IP addresses. So based on the kind of workload, like if, for example, if you have an application tier or a database, you want to keep them secure. You don't want to keep them accessible to the internet. So you can put them in a private subnet, which will have a private IP address, meaning it will not have access to the internet. And then your web-facing application, which needs to face the internet, you can put that in a public subnet, right? So there are two types of IP addresses that belong to two different types of subnets. Okay. Now, uh, what if you have your database sitting in a private subnet and you want that database to be updated from some update through the internet, right? For that, you can use what we call as a NAT gateway. So as you can see here, we have something called as a NAT gateway that if you notice it's sitting inside the public subnet. Why? Because the NAT gateway obviously needs access to the internet. But what the NAT gateway does is basically it translates your private IP address, right, into a public IP address so that that particular request can access the internet. Okay, so when basically you want to create and update your database, the connection or the request will be initiated from the database itself. So that's the advantage of NAT gateway, right? So NAT gateway does not take requests from the internet. It takes requests that are initiated by the private network, and then passes it on to the internet, and then retrieves the update, and then passes it on to the database for that particular update, therefore making your database, for example, secure, or anything else that you want to keep secure, that you only want to access through the NAT gateway through the internet, right? So this is one way of being able to, or this are two. We talked about two ways of connecting to the internet. One is through internet gateways for public-facing web servers, and one is NAT gateway for making any updates or giving access to the internet for private-facing content. Now, next is VPC peering, right? So we have, like, now let's say you have different types of applications across your teams, different teams, and they are sitting in different VPCs, but they still need to communicate with each other for different needs, right? So we have a concept called VPC peering, where you can pair, where you can create connections between different VPCs. So as you can see here, VPC A can talk to VPC B, can talk to VPC D, it can talk to VPC C, and so on, right? So as you can see, a mesh network essentially is created. I'll repeat that, a mesh network is created essentially, right? And that's how VPCs can communicate with each other, and that's what you need to know generally for VPC peering. VPC peering, that it forms a one-to-one mesh network for different VPCs to communicate with each other. Now, and yeah, this is basically what it would look like in the route table, because that particular route now would be added to each route table of each VPC so that it can recognize and communicate with the other VPC. Okay. Now, let's look at a architecture that has VPC peering for for connecting different VPCs, right? So you can ignore some components that you don't essentially know about. But if you count how many VPC peering circles are there, you have 1, 2, 3, 4, 5, right? You have 5 VPC peering circles, which is quite a lot. And if you think about, let's say you have 50 VPCs now. So are you going to say that you're going to have that many VPC peering connections, because you need to have each a peering connection between every VPC to every other VPC, because it's a one-to-one connection and it's not transitive, right? So that's difficult. So because of that, we created what we call as AWS Transit Gateway. So this is a service that basically centralizes all the network connectivity uh, between all the different VPCs. So essentially creating this sort of hub and spoke model instead of a mesh network. So VPC peering is a mesh network, one-to-one. So this is a transitive network, which basically creates a hub and spoke kind of model, where Transit Gateway is the hub, and you have all the spokes, which could be other VPCs, it could be other coming from other places as well, from your on-premise environment as well. So this is what is essentially created. And what you need to know about Transit Gateway is that it is a transitive, it allows for transitive communication. So you don't need to create routes for each and every VPC to communicate with each and every other VPC. All you need to do is create a route from each VPC to the Transit Gateway, as you can see in the picture here, right? So yeah. So now let me talk about connecting to on-premise networks, and I believe this is the last topic, right? So till now we talked about how VPCs, how network security is defined, and how VPCs can communicate with the internet and with each other, and how we can make the architecture better by using what we call as transit gateway, which makes it simpler for different VPCs to connect to each other, right? So now connecting to on-premise networks, right? Because that's going beyond the boundary of what you can do within AWS, within the boundary of AWS, right? So in order to connect to an on-premise network, for example, a data center, right? For example, basically you have an on-premise environment on the right-hand side, you have a VPC, which is an AWS environment on the left-hand side. Then you have what we call as a gateway. So you have a customer gateway which manages the on-premise side, and the virtual private gateway that manages the AWS side. But what are these actually managing? So they are managing what we call as a VPN connection. So how you can connect your VPC to an on-premise environment? Through a VPN connection, right? So that VPN connection basically will be created across the internet, and by default, two tunnels are created for redundancy. So if one tunnel fails, the other one will be operational, right? Um, and basically this VPN tunnel is what it's basically a virtual private network between the VPC and an on-premise environment. The only disadvantage or the limitation to this method of connecting is that your bandwidth is fairly limited for connection, and the bandwidth may be also inconsistent, because your VPN is going over the public internet, so you're relying on the variabilities of the public internet, right? So if you require highly reliable connections, VPNs may not be the best option. But if you're looking for just temporary connections, or you're looking for connections that may not require a lot of high bandwidth, then this is fine. Oh yeah, I also want to mention about the fact that we also have, if you have multiple VPCs, right, on the AWS side, then you can always think about using Transit Gateway, which also not only acts as a hub and spoke for within AWS, as I talked about, but also acts as a central point for between AWS VPCs and the on-premise side, right? So instead of having a one-to-one one-to-one VPN connection between each on-premise environment to a VPC, you basically would have just one connection, one tunnel to the transit gateway, and then from there, transit gateway will propagate the communication to the VPC. So that's where Transit Gateway also really helps consolidate everything into one place instead of having having to manage multiple separate connections. The last slide is what I want to talk about, which is called AWS Direct Connect, right? So AWS Direct Connect is basically supplements or complements. It can do both. The VPN connection that we talked about, and talked about the limitation of limited bandwidth, inconsistencies in the network because you're depending on public internet, right? So in order for you to have consistent bandwidth, network bandwidth, you can use what you call as AWS Direct Connect. So now AWS Direct Connect is basically um, a physical pipe between AWS and your data center. Okay, so AWS basically allows customers to have consistent network bandwidth by providing this offering as a service. And the way we do that is basically we have different direct connect partners that we partner with that already establish a communication. The animation sometimes can be really annoying. Yeah. So that establish the communication between AWS and the direct connect location, right? So this connection, the line in pink is already established by our partners, right? So then what customers need to do is all they need to do is find the closest direct connect location and either use a partner or do it by themselves, but typically they use a partner to basically create that physical pipe between between the on-premise environment and a direct connect location. And obviously there are multiple options for usage as well. But basically what happens is then you have a dedicated network connectivity. And the reason I call this as both complementary and supplementary is because uh, even using direct connect, you want to use a VPN connection for the direct connect connection itself, so that you are still secure. And on the other hand, for redundancy, what customers do is they have a direct connect pipe between the on-premise environment and AWS, and to have redundancy, they have a separate VPN that is going over the internet, a separate VPN connection that is idle, but it is established. And in any case that the direct connect connection is for any reason is not working or not available or something, then they always have the other option of going using the VPN connection that is going over the internet. And this is just because customers always want to design for redundancy, and that is the best practice, because you know if it's hardware, then it could fail anytime, right? So we want to make sure that we prepare customers for redundant architectures, so that they can make sure that their applications are still running in an event of any failure. So, on that note, I wanted to say thank you very much for listening to my presentation, and I hope it was meaningful. I hope there was some. I know there was a lot of concepts that were covered, but I hope the things that I talked about resonated with you. And if you have any questions, we still have some time, so I'm open to answering any of your questions that you might have now. I'm seeing all the chat now. Okay. Okay, so which country did you enjoy living in the most, by Nigel? Good question. Actually, I'm a little bit biased on this. So, I mean, I enjoyed living in Saudi Arabia because I spent 18 years of my life in Saudi Arabia, which is like 70% of my life. So, but I think Saudi Arabia is like a very laid back country. So it's like people, they don't have anything called career or anything. It's just like you just live your life. It's like living kind of like an island but in a desert, because that's how people talk and that's how people make you feel. It's like, yeah, just live today and like live the royal life. And so it's like, if you want to live in that feeling for a while, it's like really nice, because there's no concept of career or like what you want to do when what's your goals and stuff. It's just like, yeah, live for the day and enjoy the day and kind of a thing. So that, I guess, Saudi. But then, I think I also like living in US, because US gave me, the foundations that I needed for the rest of my life. But honestly, I actually liked all countries, because I like Dubai. India, obviously, I'm Indian, so I'm not going to say I don't like India. And then I'm living in Canada, and I actually like Toronto. I don't know about the rest of Canada, but I do like Toronto, and I live in Toronto downtown, so I do like Toronto a lot, because the food is just amazing. I mean, I lived in New York City before, and I don't know if I should say this, but I just love New York City more than I loved any other. Yeah, sorry, I love Toronto food more than I loved any other place in before. So yeah, I that's a very inconclusive answer, Nigel. But I honestly living in all countries, and maybe that's because of how my parents brought me up to like everything that they always said, wherever you are, just live and enjoy that life. So maybe that's why. And Priya, your cat looks like mine. His name is Jadu. Oh, say hi to Jadu for me. It looks like we all love cats. Great. Yeah. Thank you, Priya, Nigel. Any questions or any comments that you have for the presentation? Any feedback? I'm happy to hear about it. So we can improve our upcoming sessions and tailor the content more specifically to how our audience desires.
It was a great session, Priyanka. I thoroughly enjoyed it. So, yeah, I would probably leave it to Nigel and Priya if they have any more questions to ask.
Thanks, Raguraj. Appreciate it. Any other questions, or any what's your how do you find networking generally, and what are you looking to pursue a specific path that requires you to learn about networking, anything like that?
Hi, I'm Priya. Thank you so much for this presentation. It was so helpful, and you were right. Like, a lot of information was packed into this 1 hour, so it was great. And I just wanted to share that I'm like currently still very early in my journey. I just got my cloud practitioner certification, so up next, I would like to pursue the solutions architect. However, I'm brand new in the IT field. I was doing mental health for like 10 years, so I'm making a big career change.
Yeah,
So,
absolutely.
yeah, this is helpful.
Well, I just want to say that this is like, it's a very brave thing that you're doing, and good luck to you. And I hope some of the content that I shared today was actually some of the questions that are asked in the exam, like the and the transit gateway, for example, which is transitive and like those kinds of things. So I kind of stressed a little bit on those. So hopefully, that made sense. And also like with respect to like security groups and knackles, like which operates where, sort of those kinds of questions is what they ask. So more architectural questions, and that's why I wanted to also share like the basics of networking, basics of IP addressing. But I also would encourage, because I literally just shared the tip of the iceberg. There's a lot learned about classless IP addressing, which is this first slide. So if you want to know more about that, yeah, I mean, and there's a lot of like good content on YouTube. I also just like learned it on YouTube, and I just presented it. So I'm sure that you'll be able to do the same.
Yeah, thank you so much. Yeah, like you said, a lot was covered on the exam too so far with the cloud practitioner. So this was definitely helpful and refreshed a lot because it's been a while. So yeah, I'm just really grateful to you and for your time and everything. Thank you.
Thank you. That honestly, thank you so much. Nigel, anything?
Can you hear me?
Yes, yes.
Oh, fantastic. I was speaking earlier, but I was connected to my speaker, so I think you couldn't
sorry
hear
to
me.
interrupt. Sorry to interrupt your
it's
eating.
No, I've got nothing further to add. Thank you so much. It has been a great session. Like Priya, I'm also fairly new to tech. I just got my cloud practitioner, and I'm also studying for my solutions architect associate. Subnetting, networking was something I did kind of struggle with in the beginning, which is why I kind of came to the session, and it was good as a refresher. And yeah, it's been quite beneficial actually. So thank you.
Absolutely. Thank you. Thank you very much. And yeah, if there's nothing else, Raghav, thank you for the opportunity and thank you for your time, everyone. Have a good evening and good rest of the week.
Yeah,
You too.
absolutely. Thanks, Priyanka. I appreciate it. Yep. Thanks, everyone.
Thank you.
Bye.
Yeah. Bye.